Hello everyone, welcome to my YouTube channel. So here today we are going to be looking at momentum and impulse. So under this video we are going to solve a lot of problems under impulse mostly. So let's first define. So this is the introduction to linear momentum. So let's define what linear momentum is. So linear momentum by definition is just the product. It is the product of the mass and the velocity. So that is what linear momentum is. It is just the product of the mass and the velocity. So therefore momentum has got the symbol P. So P is equal to the product of the mass and the velocity. That is the mathematical expression of momentum. So now when we are looking at momentum, if let's say we have a big object such as a car, let's imagine that this is a car like that. So a car has got a very great mass, and let's say we have a person. As the person is running, they also produce momentum. Remember, momentum is not only dependent on the mass, but also the object has to be in motion. So because let's say the man is 70 kg, then they are moving at a speed of 7 meters per second. Their momentum, which is P, should be equal to mass times velocity. When you multiply 70 times 7, so this should be kg, this should be meters per second. So the momentum will be equal to 7 by 7 is 49. So 790 kg meters per second. So this is the momentum of the person. Now, however, on the other hand, let's say if a car weighs 1000 kg like that, then it's moving at a speed of 2 meters per second. Its momentum will be equal to the mass times the velocity, which will be mass is 1000 kg times the velocity 2 meters per second. So when we multiply, we are going to have 2000 kg meters per second. So this is the momentum. So the momentum, as you can see, it is not only dependent on the mass, but also the speed. So this means to say if a person is falling at, let's say, the 90 meters per second, let's say we change it like that, you will find that they will exert a greater momentum, which is 70 by 90. In that case, let's say if that person is falling 70 by 90, you will find that they will have a momentum of this amount. So this tells you that momentum is not only dependent on the mass, but also the velocity. So that's how come if an object is falling really fast, it will exert a greater amount of force on an object when it falls. Let's say it's from outer space, it is falling. As it falls, it will produce a lot of damage. That is as a result of momentum. So momentum is the product of the mass and the velocity. Now, since it's the product of mass and velocity, this means to say velocity is a vector. So we know now to say momentum is a vector quantity. So momentum is a vector quantity. Therefore, it means to say the direction is important. That means to say if one object, if it is moving in this direction, let's say the velocity will be considered to be positive. But if it is moving in this other direction, the velocity will be considered to be negative, depending on how you want to orient. If you want, you can exchange this negative, that other one positive, as long as you are consistent. That means to say if let's say if you want, you can put up to be positive, then down to be negative. If you want, you can do it the other way around. As long as you're consistent, the answer will always be correct. So that is what momentum is. Now, with that said, under momentum, we are going to have what we call an isolated system. So an isolated system is simply, so this is simply a physical, it is a physical system that does not interact with the environment. So this one, it does not interact with the environment. Therefore, so this is therefore the momentum is conserved. So for any system, as long as it is isolated, the summation of the initial momentum, remember P is momentum, is equal to the summation of the final momentum. So if you add, this means adding momentum will produce the final momentum. Like if whatever momentum the system begins with, it will be equal to the momentum at the end. For us to answer the next question, let's take this video for example. So if we have a cannon like that, when it is shot in this direction, what we see is that when the ball is shot, the cannon moves in the opposite direction. So that is what we call recoil. So the velocity of the cannon moves in the opposite direction, but the ball moves in this direction. So this is what we mean. Let me play that again. So as you can see, when it's fired, then the cannon moves in the opposite direction like that. So that is basically what goes on. So fired, the cannon moves in the opposite direction. So that is recoil. So let's now answer a question. So if we have been told that a 3,000 kg cannon rests on a frozen pond as shown in figure 3.8, the cannon is loaded with a 3 kg cannonball and is fired horizontally. If the cannon recoils to the right, so meaning to say it moves this side, with a velocity of 1.8, what is the final velocity of the ball? So that means to say this is what was going on. Yeah, so we are going to have something like this. So as it is fired like that, the cannon will move to the opposite side, so it has got some velocity. So that is key. So remember, when the cannon was inside here, so when it was inside before being fired, it was at rest. The cannon wasn't moving, the ball wasn't moving, so therefore the initial momentum was 0. So what are we going to have? We are going to have, remember we said that for momentum we have the summation of the initial momentum should be equal to the summation of the final momentum. So now you are going to say when it was at rest, the summation of the initial momentum should be equal to 0. So therefore, what are we going to have? So we are going to say, let me move this, just cutting it. Okay, then copying. So now, when we have the initial is 0, now remember we have for momentum, we add whatever is the initial. Now for the sake of understanding, let's just add first. We have momentum. Remember we said that it is the product of mass and velocity. So we are going to say initial momentum, we add for the cannon, which also moved and the ball. So we have the cannon, let's call it the mass number 1, if we add the mass number 1, let's say mass number 1 is for the boat times velocity number 1 plus the mass number 2 for the cannon times the velocity number 2. That is for the initial. We put initial like that should be equal to the summation of the final mass. This mass is the same, so m1 times the velocity number 1 final plus the mass number 2 for the cannon times the velocity of number 2 final. Now remember, we said summation is to add, so just add the initials like that. So now remember, the velocity, initial velocity is 0, and here the initial velocity is 0. So that's how come here when we say summation of initial momentum, we say 0, but we can still calculate by saying the mass of the, not the cannon first. Okay, anyways, the cannon is okay, so we can say 3000 by so the mass has to be in kg by 0 meters per second. It wasn't moving. Plus mass number 2, we are told that the mass number 2 is 3 kg, so we are going to say plus 3 kg times a 0. It wasn't moving as well, so that's how come here we are going to have a 0, then should be equal to mass number 1, which will be equal to, we said that this is 3000 kg. We are told that it recoils, it moves to the right with 1.8, so 1.8 meters per second. So we are going to put it there and say times 1.8 meters per second plus what is the mass number 2. Let me reduce the font. The mass number 2 is 3 kg for the bow, the cannon bow. So we have the cannon bow is 3 kg times the velocity it will move at, we don't know, so v2 final. So as you can see here, this times 0 is 0 plus 0, which will just be 0, should be equal to, when we multiply our 3000 times 1.8, this is going to give us a 5400 kg meters per second plus 3 kg v2 final. So that this, when it goes, so we have 0 should be equal to 5400 kg meters per second plus our 3 kg v2 final, like that. So when this goes this side, we are going to have negative 5400 kg meters per second should be equal to 3 kg v2 final, like that. So we are going to now divide 3 kg. We are going to divide 3 kg so that we are going to have our v2 final will be equal to, when we divide 5400 divided by 3, we are going to have a negative 1800 kg cancel. We are going to remain with meters per second. Now this is important. The negative shows you that it shows you that it was moving in the opposite direction. So the direction is important. If 1.8, which was moving to the right, is positive, then that means we say this one has to be negative, like that. So the direction is very important under linear momentum. Now with that said, what is impulse? So impulse is defined as the force applied, that is impulse in terms of net force, is the force applied over a short period of time, over a short period of time. So that is impulse. So impulse has got the symbol J, so that is impulse. So impulse is the force applied over a short period of time. But depending on your lecturer, you can just be writing the full word. So impulse is equal to the force applied over a shortest period of time, so times the change in the time, like that. So that is basically what impulse is in terms of net force. impulse in terms of momentum. So impulse in terms of momentum. So impulse in terms of momentum is the change in momentum. So that is impulse in terms of momentum. So impulse should be equal to the difference. Change is a difference. So impulse is equal to the difference, which is the summation of the final momentum minus the summation of the initial momentum. So that is impulse. So it is the change in the momentum. So let us answer a question. So we are told a golf ball of mass 50 grams is struck with a club. The force on the ball varies from 0 when contact is made up to some maximum value where the ball is deformed, and then back to 0 when the ball leaves the club. Assume that the ball leaves the club face with a velocity of 44 meters per second. Estimate the impulse to the collision. So let's say we have a golf ball. Let's say we have a golf ball which is here. Then we have a club like that. You want to hit the golf ball like that. So now what happens is that as the golf ball is here, there is no contact. This club does not have any velocity. As someone is moving it, as they move it, it gains velocity like that. Then when it strikes the ball, then the ball now gains the velocity of 44 meters per second, according to what we are told. So this means to say initially, without this moving, when it is just here, it has no momentum, and this one has no momentum. Therefore, the initial momentum is 0. So let's calculate the momentum for the 50 grams, the golf ball, 50 grams struck with a club like that. So this is our club, this is our ball. So when it is struck like that, what are we going to have? So the momentum now, let's calculate the momentum. So the final momentum, okay, let's begin like this. So initial momentum is equal to 0 kg meters per second. Why? Because they were both at rest. Then when we have the final momentum, the final momentum should be equal to, we are going to now calculate the product of the mass times the velocity. The mass has to be in kg, so 50 grams, let's convert 50 grams. If you want, you can be doing what you are used to, which is 1000 grams should be equal to 1 kg. How about 50 grams? You don't know, so you cross multiply this times x, it will be 1000 grams. X should be equal to 50 times this, it will be 50 grams times 1 kg. We divide by 1000. We divide by 1000 so that our x should be equal to, we are going to have 50 divided by 1000. This is going to give us a value of 0.05 kg. So the momentum, final momentum or P final, should be equal to the mass times the velocity. Mass is 0.05 kg times the velocity, which is 44 meters per second. So when we multiply this value by the 44, we are going to get a 2.2 kg meters per second. So this is our final momentum. So if that's the case, if this is our final momentum, we can now be able to say impulse should be equal to the summation of the final momentum minus the summation of the initial momentum. which will be equal to the final momentum is 2.2 kg meters per second minus the initial momentum, which will be our 0 because it wasn't moving, it was at rest at first. So kg meters per second. So when we subtract, 0 doesn't change anything, so we are just going to have this meters per second. So this is the impulse, which will be our J like that. So this is basically how we calculate the impulse like that. So the impulse has got the same units as momentum, or you can have these as the Newton second as the other units. So now with that said, let's move on to the second part. Estimates the average force of the ball when if the contact time is this. So using the second one, we want the force now. So the impulse is equal to, we are going to have the product of the force times the smallest amount of time. So that's how come even the units are Newton second, because force is Newton, time is second. So we are going to have the impulse, we are going to replace, impulse should be equal to 2.2 Newton second, should be equal to the force times the time. We are told that the time is 4.5 times 10 to the power of negative 4 seconds. 4.5 times 10 to the power negative 4 seconds. So we divide this 4.5 times 10 to the power negative 4 seconds over 4.5 times 10 to the power negative 4 seconds, which will be equal to, force should be equal to 2.2 divided by our 4.5, not 45, 4.5 times 10 to the power negative 4. This is going to give us a 4,888.9 newtons. So this is the force. This is the average force. Now let's move on to some challenging questions on impulse. So these are the questions we are going to solve. This one, and this one. So we have a billiard ball of mass 50 grams moves with a velocity of 4√3 meters per second, strikes a rigid wall and gets reflected without any loss of speed, meaning to say the speed is the same. Calculate the impulse imparted on the ball if it strikes normally on the wall. Okay, so I forgot to put the diagram here. So the diagram is like this. Yeah, so we have the diagram like this. So we have a wall, then we have a ball like that. So this ball, is it a ball? A ball, a billiard ball. So it is thrown normally with the wall. It means to say at a 90 degrees angle. And if something is thrown with a 90 degrees angle, whatever it strikes, it will go back in the same exact path. So that is the meaning of throwing something normally like that. So that's basically the meaning of throwing it normally. So therefore, this is totally in the x-axis. So to calculate the impulse imparted, remember how we calculate the impulse. Let me increase this. So remember how we calculate the impulse. So the impulse will be equal to the force applied, or the initial momentum minus the final momentum. So what are we going to do? Let's calculate the momentum. So remember, going this side as the ball is going this side, it will be positive x. As it is going this other side, coming back, it will be negative x as it is coming back like that. So you have to be consistent. So that's the velocity in terms of the impulse. So you're going to say your impulse will be equal to the summation of the final momentum minus the summation of the initial momentum. Now remember, the momentum is equal to the product of the mass times the final velocity. That is the final. Remember, we can say final is equal to mass times the final velocity. Now we have just replaced everything here, minus the initial momentum will have the velocity initial. Now why are we just using 1m? Because m, we only have one mass of the ball like that. So that is what we have. So therefore the impulse, to make our work easier, we are going to put the mass, factorize the mass. Mass is common. We are going to remain with final velocity minus the initial velocity like that. Now let's have the mass is 170 grams. So let's identify initial velocity is equal to, so as it is moving, so taking this to be positive, taking this direction, so the initial to be positive, it will be this value 4 roots 2. So we are going to say 4 roots of 2 meters per second. Then the final, it will come back. So if it is at 90 degrees or whichever path it goes, it will come back like that. So this one, we are going to attach a negative because it's going back the same. So it's a negative. We are going to have the final velocity will be negative 4 roots of 2 meters per second like that. So this is our final velocity. So we can now also the mass, which is equal to 170 grams. Without wasting time, if you are converting to grams to kg, if you have grams, just divide by 1000. So the mass will be equal to 170 grams over 1000. If you want, you can do what we did. So the mass will be equal to 0.17 kg. So we can replace. So we have said that the impulse, we have made it to be equal to mass, open brackets, velocity, final velocity minus the initial velocity like that. So we have the mass, which is 0.17 kg times the velocity, which is equal to the 4 roots of, our final was a negative, where was it? So we found our final to be negative, this one. So we are going to say the negative 4 roots of 2 minus the initial was positive. So we have our 4 roots of 2 like that. So we are going to have 0.17 kg like that. Then we have, if you subtract negative 4 minus 4, as long as you have the same thing, you can just subtract normally. 4 minus 4 is negative 8 roots of 2. So when you multiply this, you are going to get a value of 0.17 times 8 root of 2. This is going to give us a value of negative 1.92 like that. So this is the impulse. So this impulse is equal to negative 1.923 Newton second. So this negative tells you that the impulse imparted should be equal to 1.923 Newton second in the opposite direction. In the opposite direction as initial motion. So we have answered that. Let's try out this one now. when it is both in the x and the y. Let me move this. Now here you need to be very careful. If we have an horizontal wall like that, what we always use is the angle between the normal and where it was drawn. So in this case, we have been told that it strikes at an angle of 45 with the normal to the wall, meaning to say it moves like that. Then this angle will be 45. So with the normal to the wall. So with the normal, meaning to say the angle is this one is the normal, the one that is drawn perpendicular. So this is the normal. So then it will come back like that. Same angle, 45. Like that. So that is the property of the 45. So this is what we have. So it was coming like that. So we always use, if it is a vertical wall, we always use the angle between. But even if you use this for this question specifically, 45, we know that this is 90. 90 minus 45 is 45. But for other problems, in fact, for all problems, you just use this angle if you have a vertical wall like that. So I'm emphasizing on that. So therefore, what are we going to have? So it strikes at an angle 45 degrees with the normal to the wall. So what are we going to have? We are going to split this momentum in the x and the momentum in the y. So let's first begin by resolving in two components. So resolving velocity components. So remember, this velocity is at an angle, so therefore you need to resolve it. Now what we are going to do is that as long as it is moving this direction, we are going to consider it to be positive x. Now this is in terms of the y, it's just going down, so it is better we just put y to be positive as long as it's going down. So as long as we are consistent, it will come out correct. So resolving the velocity into its components, what are we going to have? So we are going to get a value such as in the x, the velocity, which is the velocity initial, that is in the x, will be equal to the v cos. So remember, the x component is the cos. So if it's like that, the adjacent, so if this is 45, x is the adjacent, so x will always be accommodated by cos, if you remember your vectors. Then we are going to say the v, remember the velocity is 4 root 3, so we are going to put that 4 root 3 here. So 4 root of 3 times the cos of, what is our theta? Theta is 45 degrees. So is it root 3? Root 2. Root 2, yeah. So we are going to have our 4 root of 2, times the cosine of 45. This is going to give us a value of 4. So the x initial is equal to 4 meters per second. So now remember, so in the velocity final of x will be equal to, so remember it strikes here, so it strikes, let me just redraw it. So it's like this, it goes like that, so it is moving in this direction, it's positive. So going back in this other direction, we are told that it moves with the same velocity, so it will just be the same, but it will attract a negative because it is moving in the opposite direction. So it will be negative 4 meters per second. Then in the y, the y, in the y, we are going to have the velocity will be equal to v sine of theta, which will be So v y initial will be equal to, so it was projected at 4 roots of 2 sine of 45. So when you press this, the sine of 45 and the cos of 45 is the same. So therefore the initial velocity will be the same, which will just be a 4 meters per second. The final velocity in the y will be equal to, I think it will be better if I put, the final velocity in the y will be equal to 4 meters per second. This one will not be negative because it is purely going down. So it began with going down, it is still going down, unless if it went up. So if it went up whereby we have it was going down, then it comes up like that. But this case it's going down, so even its final velocity in the y will be a 4 positive for that matter. So what are we going to have? So we are going to say, let's try in the x. In the x, the momentum, so we have to split this. If it gives us a different answer, if there is momentum in the y as well, we are if there is impulse in the y, we are going to use Pythagoras theorem. We are going to look at another example where that is mostly applicable. So we are going to have the impulse in the x will be equal to the summation of the final momentum minus the summation of the initial momentum. So remember we said final momentum will attract the velocity x final. I think it will be better if I say velocity like this, minus the mass times the initial velocity, which will be initial x, so that we factorize the m, we are going to have vfx minus vix. Our mass, we found, we have already converted it to be 0.17 kg times the final velocity, which is equivalent to our final velocity in the x direction, remember, is -4. So we have -4 meters per second minus the initial velocity in the x was 4. So minus the 4, it will be equal to 0.17 kg times -8 meters per second. This is going to give us -8 times 0.17. This is going to give us a value of -1.36. So this is the impulse in the x. Then the impulse in the y. Impulse in the y will be equal to, same thing, we have the impulse should be equal to the mass, final velocity in the y minus the initial velocity in the y. Mass 0.17 kg by the final velocity. Remember the final velocity is 4, initial is 4, so they are both positive. So we are going to have 4 minus 4 meters per second, which is going to give us 0.17 kg times 0 meters per second, which will just be equal to 0. So this is the impulse, 0 kg meters per second. So that means to say the impulse is just purely in the x-axis. So therefore we can say impulse should be equal to -1.36 Newton second, or if you want kg meters per second, it's still okay. So we are going to have, that's our impulse. Then the magnitude of the impulse, you're just going to remove this sign and say it will be equal to 1.36 Newton second. So that's the magnitude. So you can even include the fact that you're going to say in the opposite direction. So it was moving like that, but in terms of the x, it has changed the direction in the x. So let's move on. Let's look at another question. Let's say we have this one. A 3 kg steel ball strikes a wall with a speed of 10 meters per second at an angle of 60 degrees with the surface. It bounces off with the same speed, mass, and angle as shown below. If the ball is in contact with the wall for 0.2 seconds and the wall is undamaged, what is the average force exerted by the wall on the ball? What is the impulse? So the way it was, we are going to answer B, then answer A, because we cannot answer direct A without finding the impulse. So therefore, let's be able to answer that one. So remember what I said. If it is a vertical wall, you take the angle made with the normal. So here you need to find this angle. So you know to say 60. So if this angle is 90, so that means to say, if let's say this is x plus 60 degrees should be equal to 90. So if you add x and 60, it will be the 90, which will be x will be equal to 90 degrees minus 60 degrees, which will give you 30 degrees. So this is our angle there. So even here we are going to have 30 degrees since this is also 60. So with that done, what are we going to have? So we are going to get a value that is equivalent to. So the first thing that you need to do, since it was at an angle, find the x and the y velocity. So you are going to say v initial x should be equal to v cos of theta. So if you messed up the angle, that means to say you are going to get it wrong. So we have the velocity, the initial velocity, it was 10. Now it is at an angle, so we are going to say 10 meters per second times the cos of the angle, which is 30 degrees. So this is going to give us 10 cos of 30 gives us 8.66. So we have 8.66 like that, cos of 10.66 meters per second. So this is the initial. If the velocity is the same, remember we are told that according to this question, strikes the wall with this speed at an angle of that, it bounces with the same speed. So therefore, but since it's bouncing, it is changing its x direction. So remember, positive x, negative x going back. So we are going to have v final for x will be equal to just the negative value, 8.66, since the angle is not changing. If the angle was changing, we could have done the 10 cos of that, but adding a negative. We are going to look at another question where the angle is changing. So this is the one for in the x, then in the y, v iy should be equal to v cos of theta. Our velocity is 10. Sorry, the y is associated with the sine. So we are going to put sine of our 30 degrees. This is going to give us 10 sine of 30 will be equal to 5. So this is our y. V final in the y direction will still be v sine of 30, which will be the 10 sine of 30, which is equal to 5 again. So why isn't it changing? Why isn't it negative? Remember, it is moving like that. So it is moving down throughout. Therefore, it is moving down. Therefore, it is positive throughout. But for x, it was moving in this direction, then started coming back in the other direction. That means to say, you have to differentiate them. But this one is positive throughout like that. So that means to say, the impulse will be equal to impulse in the x will be equal to, long story short, mass, open brackets, final velocity minus the initial velocity like that. So that is in the x. So the mass, we are provided with a mass which is equal to 3 kg. So we are going to put our 3 kg like that. 3 kg times, what is our final velocity for the x? It's negative 8.66. So we are going to have negative 8.66 meters per second minus the initial was positive 8.66. So we are going to have 8.66 meters per second. So that we have, let me put it here, 3 kg times, if I subtract my negative 8.66 minus 8.66, this is going to give me a negative 17.32 meters per second. So the impulse will be equal to, if I multiply 3 times 17.30, it's going to give me negative 51.96. So this is the impulse. So the impulse is equal to negative 51.96 like that. So if this is the case, we can now be able to say the average force exerted. So we have answered B. So after answering this, we need to now answer this. So we can say force, we know that the impulse is equal to force times the change in time. Impulse is negative 51.96. Our force is equal to, we don't know, times the time. We have been told that it strikes the wall at 0.20. So it maintains contact for a period of 0.20. So we have our 0.20 seconds. We divide it by 0.20 seconds. 0.20 seconds. That is going to give us our force to be equal to, divided by our 0.2. This is going to give us a negative 259.8 newtons of force. So the magnitude of the force, meaning without direction, will just be equal to positive 259.8 newtons. So now you might be wondering, why is it that we have just used this impulse? What about impulse in the y? Let's try to find it. Impulse in the y. Impulse in y will be equal to the mass, open brackets, v final minus v initial. Now remember, the mass is 3 kg. The initial velocity, or the final velocity, is 5. Where is it? It's here, 5. Both of them have got the same sign, therefore no momentum unless the angle changes or the speed changes. So we have, if we say 5 minus 5 meters per second, this is going to give us a 0. So that's how come the impulse is entirely dependent on the x, for this question. Not that for every question, no, for this question, like that. So we have answered our force magnitude. So for B, where it says impulse, we are just going to label its impulse should be equal to, we found it to be negative 51.96 Newton second. Then that means to say magnitude of impulse without the negative, it's 51.96 Newton seconds. Yeah, so that is how we answer that one. Let's look at these statement questions. It says that what was the total brief deformation of the ball and the wall? So deformation is more like a change in the shape. So what can we say about that one? So this one is a temporally elastic deformation. So what does that mean? So for C, temporally elastic deformation. So as the ball strikes an object, the ball initially just changes the shape. So if we have, let's say the ball is like this, so as it strikes, it's more like to absorb the impact, it changes the shape. Not like that, but yeah. So we have something like this. Then when it goes back, it maintains its original shape like that. So that is temporary, meaning to say it returns to its original shape and size. So that is what we call a temporary elastic in the sense that it is returning to its original shape. So temporary elastic deformation. Then for the next one, it was saying that what type of collision is depicted in this scenario? This is a perfect elastic collision. Why is that? Because remember, for perfect elastic collision, the momentum is conserved. That's number one. So if you were asked for a reason D, it is a perfect elastic collision. For the reason momentum was conserved, though for inelastic collision still momentum is conserved. So you can add momentum is conserved but also the kinetic energy is conserved. Why do we say that it is conserved? Simply because the speed is the same. It strikes, it goes back, the speed is the same. Remember, kinetic energy is equal to half mv squared. Mass is the same, it's the same object, half, this is a constant. So if the velocity it remains the same, it means to say even the kinetic energy will be the same. So if the kinetic energy is maintained, it means to say it's a perfect elastic collision if the kinetic energy is not lost. Last but not the least, for this problem, we are going to have defined the different types of collisions, though we wanted to go into collisions in a different video, but we can define them. So we have perfect elastic collision. So they do not, under this one, perfect elastic collision, they do not stick to each other. So I'll just be writing first, do not stick to each other. They strike, then they move in opposite direction, or they can move in the same direction, but they do not, the fact is that they do not stick to each other. That's the perfect elastic collision. The momentum is conserved, so P, so momentum is conserved. Also, what else is conserved? Kinetic energy is conserved. So kinetic energy is conserved, momentum is conserved, they do not stick to each other. Then when we look at elastic collision, sorry, not elastic, inelastic collision, they do not stick to each other. Okay, for this one, not necessarily stick to each other. Let's just put kinetic energy is lost, momentum is conserved. Like for example, if two cars collide with each other, they damage themselves and there is a reduction in speed. Since speed is lost, it means to say the kinetic energy is lost. Now there is also the aspect of perfect inelastic collision. So under the perfect inelastic collision, this one we are going to have momentum is conserved. This one is momentum is conserved. Also kinetic energy is lost. Now what's the difference between perfect inelastic and elastic? Perfect inelastic is, let's say two asteroids strike each other, they are moving in space, then they strike each other, then they form one mass. That is what we call perfect inelastic collision. So they stick to each other. So that is that. Let's answer our last question. So we have a ball of mass 200 grams glances off a wall as shown in the diagram below. The ball approaches at 15 meters per second at theta is equal to 30 degrees and leaves at 12 meters per second. The collision lasts for 15 milliseconds. What is the magnitude of the impulse experienced by the ball? What is the magnitude of the average force exerted by the ball? So we want the impulse. So if the wall is horizontal, the angle you are going to use are these angles. If the wall is vertical, the angle you are going to use is the one between the normal and the angle of more like throwing, like that. So that is very, very important. So the first thing that we are going to do is let's find the momentum, or let's resolve the velocities. So we can say velocities in the so we have the velocities when we resolve them. The velocity in the x initial, or should I say the velocity x initial, should be equal to the v cos of theta. So this is our initial. So approaches at theta. So this is our initial. Then this is our final angle, which is our 20. So we are going to have, it is approaching at 15, cos of the angle 30 degrees. Is it 30? So we have 30 degrees. So VIX should be equal to, when we say 15 cosine of 30, this is going to give us a value of 12.99 meters per second, like that. So this is the velocity in the x for the initial. Let's answer the final velocity in the x. So the final velocity in the x, is it possible to move it side by side? So I've just moved the initial there. So the velocity in the in the x, we are still in the velocity final in the x will be equal to v cos of, now the angle, be careful, it's this one. So we have something like this. So it leaves at 12 meters per second. So we are going to say 12 meters per second, cos of the angle 20 degrees. So we are told that it leaves at the angle of 20 degrees. So this is going to give us 12 cosine of 20. We are going to have 11.28 meters per second, like that. So this is all in the x. Let's find in advance for the y. For the y, the v initial y should be equal to v sine of theta, which will be the velocity initial. Let's be careful. Velocity final, since it's changing, velocity initial. So the velocity initial is 15, sine of the angle is 30, which will give us 15 sine of 30. This is giving us a value of 7.5. So remember, the x, if you make x to be positive in this direction, that means to say x will be positive throughout, like that. However, for the y, it is, as you can see, as it is going like that, it's going down. As it is going like that, it's going up. So therefore, we are going to say that this velocity, let's take up to be positive, then down to be, just positive. That means down will be negative. So we are going to have this one that we have found, 15 sine of that, we are going to put a negative. So why put a negative? Simply because it is going down. Let me move this. The v final in the y should be equal to v2 of v final sine of the theta. So it is 12 sine of the theta is 20, not that theta, but this one. So we are going to have 12 sine of 20. We are going to get a 4.1. So VFY is equal to 4.1. Why is it positive? Because at this point it is moving up, like that. So therefore, now let's find the impulse in the x after resolving them. So we have the impulse in the x. So the impulse, we are going to say, should be equal to the summation of final momentum minus the summation of initial momentum. So which, just a reminder, mass times the final velocity in the x, since we're dealing with the x, minus the mass times the initial velocity in the x. So we have mass is common. Remember this formula. So we are going to have, what is our mass? Our mass for this one is 200 grams. So just divide by 1000 if it is in grams. 200 divided by 1000 grams will give us 0.2 kg. So we are going to be using 0.2 kg times, what is our final velocity in the x? So according to this, final velocity in the x is 11.28. So we are going to have 11.28 minus, let me move this a bit, (11.28 meters per second) minus the velocity initial in the x will be equal to, velocity initial is 12.99. So we have minus our 12.99. We are going to have 0.2 times, if we subtract 11.28 minus 12.99, this is going to give us a value of negative 1.79 meters per second, kg there. So our 0.2, when we multiply it by 0.1 by 1.71, this is going to give us a value of a negative 0.342. So this will be the impulse in the x Newton second. Impulse in the y will be there because the speed is changing. Impulse in the y. So the impulse in the y will be equal to mass, remember this formula, velocity final in the y minus the velocity initial in the y. Mass 0.2. The velocity final in the y, we found it to be 4.1 meters per second. So we are going to say 4.1. Let's move this. 4.1 meters per second minus our initial velocity in the y will be equal to negative 7.5. Negative 7.5 meters per second. So we are going to have 0.2, 4.1 meters per second plus 7.5 meters per second. This is going to give us 0.2 kg times 4.1 plus 7.5. This is going to give us a value of 11.6 meters per second. When we multiply by 0.2, we are going to have a 2.32 kg meters per second. So we have found, so this is our impulse, Jy. Allow me to say Jy. Impulse is J. So to find the magnitude, remember the Pythagoras, the magnitude will be equal to the square root of the square of the impulse squared, impulse in the x squared plus the impulse in the y squared, because we have found in both the x and the y. Never forget Pythagoras. So we have the momentum in the x is negative 0.342 squared plus the 2.32 squared. This is going to give us a value of, this is going to give us a value of 0.342 squared is, so we have 0.11. Okay, let's just add what is inside plus the 2.32 squared. This is going to give us a 5.499364. When we find the square root of this, we are going to have a value of 2.3435 Newton second. So this is the magnitude of impulse. You can just write it properly like that. Then the last question, which is part B, says that we have what is the magnitude of the average force experienced by the ball. So for this one, we are going to have our force impulse should be equal to, we have the force times the change in time. So the impulse is found to be, you use the magnitude, 35 should be equal to the force times the time. So what time? What is our time here? So the time is 15 milliseconds. Milli is 10 to the power negative 3. Never forget that. Never forget your prefixes. So we have 15. We are told that it's millisecond, but where there is milli, we are going to put times 10 to the power negative 3. So 15 milliseconds. Milli is, this is 10 to the power negative 3. Never forget that. So we have the seconds there. We divide this 15 times 10 to the power negative 3 seconds over 15 times 10 to the power negative 3 seconds. This is going to give us, the force will be equal to 2.35 Newton second over 15 times 10 to the power negative 3 seconds, which will be equal to this divided by 15. So 2.35 divided by our 15 times 10 to the power of negative 3 will give us a value that is equivalent to 156.67 newtons. So that is how we deal with impulse questions. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.